Hello students, now we will start with unit 3, functions of certain variables, and the topic is Jacobian functions. So let's start the outline. So we have introduction, next we have defining a Jacobian matrix, followed by problems, and finally we have the assignment problems. So let's start off with the introduction. Jacobian matrix was developed by Carl Gustav Jacobi, a German Jewish mathematician. The Jacobian can also be used to solve systems of differential equations at an equilibrium point or approximate solutions near an equilibrium point. Its applications include determining the stability of the disease-free equilibrium in disease modeling. So let's start up with defining a Jacobian matrix. So we have two cases, Jacobian matrix in Cartesian coordinates and Jacobian matrix in polar coordinates. So first let's start up with Jacobian matrix in Cartesian coordinates. So how do I define Jacobian matrix? So we have a two variable xy and another two variable uv. So Jacobian matrix can be defined for two variables over two variables or three variables over three variables. So this is how it is defined. We use partial derivatives here. Dou of x comma y upon dou of u comma v is equal to determinant of, take the first variable and append the first variable to the denominator. Okay. So this is going to be dou x upon dou u, dou x upon dou v, and dou x upon dou w. So while substituting all the entries here, so while expanding, we will be getting it as u squared v. Now problem number 4. Here we are going to make use of the property number 2. So I'll go back to property number 2. Property number 2 says that dou of x comma y upon dou of u comma v multiplied by dou of u comma v upon dou of r comma s is equal to dou of xy upon dou of rs. So here, make sure you remember the second property. And so this is x and y are related in terms of xy, and whereas x and y are related in terms of r and theta. So they're asking you the direct connection of dou uv upon dou r theta. So which means first I have to start from uv and then go to xy, and from xy I have to reach this r and theta. So I need two Jacobian matrix here. So this two matrix will be, one will be dou of uv upon dou of xy, and the other one is dou of xy upon dou of r theta. So I guess everybody knows that the entries of this particular determinant, dou u upon dou x, dou u upon dou y, dou v upon dou x, and dou v upon dou y. Substituting all these values while differentiating, your answer will be this. And moreover, you know that x square plus y square is equal to r square. So minus 4 into r square, and here taking r outside, you will be getting cos square plus sin square theta, which is 1. And this r square and r will become minus 4 r cube. And now students, these are the two assignment problems which has to be done by you. So it's a very simple problem, and I've asked you to calculate the Jacobian of xy upon uv, where x is given as u of 1 plus v and y is equal to v of 1 plus u. The second problem, x is given in terms of u and v, y is given in terms of u and v, and they're asking you to find the Jacobian of xy with respect to uv, which means this is the same formula you have to use for the second one too. Okay, thanks for watching the video.